Today we are going to discuss about the analysis of coal. Already you know that the coal is an example of the solid fuels. Similarly, petroleum is an example of liquid fuels and so on. Today we are going to discuss about the how the coal is analyzed. The coal, it is mainly composed of carbon, hydrogen, nitrogen, and oxygen, and along with these elements, some non-combustible inorganic matter also will be present. So, in order to find out what is the percentage of carbon, hydrogen, nitrogen, oxygen, and apart from this, some volatile matter, moisture, in order to find out what about all these contents that are present in a particular coal sample, the analysis must be performed. So, this study the means nothing. The analysis of coal is mainly divided into two types. I mean, into two divisions, namely proximate analysis and ultimate analysis. Coming to the proximate analysis, in proximate analysis, we will determine the amount of moisture, volatile matter, ash, and fixed carbon that is present in the coal. This approximate analysis gives very quick and valuable information because with the help of this information, it can be used for the particular mainly for the industries in the sense mainly pharma industries all will be using coal for removal of the impurities and all in the manufacturing process. So with the help of this proximate analysis, they will come to know about the quality of the coal that is present, and it will help for the industrial application. Coming to the second type of analysis, that is the second part of analysis, nothing but the ultimate analysis. In this it includes the determination of the carbon, hydrogen, nitrogen, sulfur, and oxygen. Carbon, hydrogen, nitrogen, sulfur, oxygen, all these are the elemental analysis. These are the elements that are present in the coal. As the analysis is performed to find out the percentage of the elements, this analysis is also called the elemental analysis. The ultimate analysis will be useful for calculating the calorific value of the coal. Actually, this calorific value can be determined by the Dulong's by using Dulong's formula. The ultimate analysis will help us to find out the calorific value of the coal, and the proximate analysis will help further will help to estimate the quality of the coal for industrial application. So let us discuss about the proximate analysis in detail. Okay, first comes the moisture content. In order to find out the moisture content that is present in the coal, first 1 gram of finely powdered and air dried coal sample is taken, and it is weighed in a crucible. The crucibles are nothing but the small white colored small miniature type dishes that are used for heating the samples in the furnace at very high temperatures. Okay, so the coal samples are placed in a crucible, and then it is placed inside an electric hot air oven, and this oven must be maintained at 105 to 110 degrees centigrade. Okay, once they are placed in the oven, which is maintained at a temperature of 105 to 110 degrees centigrade, it is allowed to place in an oven for 1 hour. Okay, the coal is heated at this temperature for 1 hour, and then it is taken out, air dried, and it is cooled in a desiccator, and the weight of the crucible with the sample is found out. Now, loss of the weight is calculated by using this formula. Percentage of moisture is equal to loss in weight by weight of the coal taken into 100. Loss in weight means the difference in weight of the sample before placing it in the oven and after removing it from the oven. Means after 1 hour, the weight of the sample is measured, and the difference will give the loss in weight of the loss in weight of the sample, means the moisture that is present in the sample is lost. So the percentage of moisture is calculated by using this formula. The next comes the volatile matter. In order to find out the volatile matter content present in the coal sample, first the dried sample of the coal that is left in the crucible, that is the moisture free a coal sample is taken, and then it is placed and then it is covered with a lid and placed in an electric furnace, which is nothing but the muffle furnace. The same crucible must be used in muffle furnace also. But the temperature that has to be maintained in the muffle furnace is 925 degrees centigrade. Plus or minus 20 means the temperature can be maintained between 905 to 945 degrees centigrade. Between these temperatures, the muffle furnace must be maintained. Once the crucible is placed, it is allowed to expose to this temperature for about 7 minutes. For 7 minutes, the sample must be heated in the muffle furnace. Once the 7 minutes is done, the crucible must be taken out, and it is cooled and placed inside the desiccator. And again, the loss in weight must be calculated. The formula for calculate the percentage of the volatile matter it can be calculated by using the formula loss in weight due to removal of the volatile matter by weight of the coal sample taken into 100. The next analysis is the amount of ash that is present in the coal sample. Okay, the residual coal in the crucible, that is in the above step, is taken, and then it is heated without lid in the muffle furnace at 700 plus or minus 50 degrees centigrade for half an hour. Then the crucible is then taken out and it is cooled in air, and it is the same procedure is followed. It is cooled in a desiccator, and again it is weighed. Here what you have to know is the heating, cooling and weighing is repeated till a constant weight is obtained, not only in the ash content but also in the volatile matter also. The constant weight must be obtained. If the constant weight is obtained, then only the value can be taken as an accurate value. Similar, the percentage of ash can be calculated by using the formula weight of the ash left by weight of the coal into weight of the coal taken into 100. Next comes that is a fixed carbon. This fixed carbon also, fixed carbon is different from the carbon content. Okay, this fixed carbon can be comes under the proximate analysis, and it can be calculated by using the formula 100 minus the percentage of moisture, volatile matter and ash. The above three analysis values is subtracted from 100, then we will get the fixed carbon content. The high percentage of ruined carbon is desirable. Now, we have discussed about the proximate analysis. Now, let us see what is the importance of proximate analysis. Sorry, just a second. Mm, yes. Now comes the importance of proximate analysis. The proximate analysis provides some important information. If the moisture from we in proximate analysis, we have found out the moisture content. This moisture content value will help us to know the effective calorific value of the coal. Okay. Moreover, it quenches the fire in the furnace. If the calorific value, the coal is used to quench the fire. If the moisture content is known, then if is known, if lesser amount of moisture content is present, then the quality of the coal is considered to be good. The presence of moisture content up to 10% produces more uniform fuel bed and less of the fly ash. If fly ash is more, then the quality of the coal is usually considered to be of a less quality. So if the moisture content is up to 10%, if the value is up to 10%, then it is considered to be more uniform fuel bed, and it is of considered to be the good quality. The next comes what is the importance of the volatile matter. If we come to know about the volatile matter, the percentage of volatile matter that is present in the coal, then what will be the useful value that, or the useful information we get from that analysis is the high volatile matter containing coal burns with a low flame, so high smoke and has low calorific value. Hence, lesser the volatile matter, better will be the quality of the coal. Higher volatile content in coal is undesirable means the higher amount of volatile matter should not be present in the coal. Next, we have calculated the ash content also. Okay, the coming to the same point is it is explained here also. The high volatile matter content means a high proportion of the fuel will be distilled and it is burned as a gas or the vapor. Means volatile matter is nothing but the matter that is easily evaporated, that easily converts into the vapors form. So the volatile matter present in the coal may be combustible gases such as methane, hydrogen, carbon dioxide, and other hydrocarbons. So all these are, if all these are present in the coal, they come under the volatile matter. And when coal is heated, all these gases like methane, hydrogen, all these will be evaporated. Okay, and apart from this, some non-combustible gases also come under volatile matter of the coal, that is carbon dioxide and nitrogen. Okay, the volatile matter content is of special significance in coal gas manufacture and in carbonization plants, particularly when byproduct recovery is a main object. Thus, high volatile matter containing coals do not cake well, whereas medium volatile matter content coals are capable of yielding hard and strong coke on carbonization. Okay, the third one is a ash content. If we come to know the value of the ash content, what type of information we will gather? Means the ash is a useless and non-combustible matter which reduces the calorific value of the coal. If the percentage of ash content is more, then the calorific value of the coal will be very less, which is not desirable actually. Okay, moreover, the ash causes a hindrance to the flow of the air and heat, thereby lowering the temperature. Also, it often causes trouble during firing by forming clinkers. Clinkers are nothing but the small stone residues. If ash content is more, then clinkers formation will be very high, and these clinkers will block the interspaces of the grate. Okay, this in turn causes obstruction of the air supply, thereby burning the coal. Thereby burning of the coal becomes very irregular. Okay, and hence the lower the ash content, better will be the quality. The presence of ash also increases transporting, handling, and storage costs. So obviously, if ash content is more, then all these problems will arise. The presence of ash also causes early wear of furnace walls, burning of apparatus, and feeding mechanisms. Finally, the last one that we have found out is a fixed carbon, and the importance of the significance of the fixed carbon is higher the percentage of fixed carbon, greater is its calorific value. Better and if the calorific value is more, then obviously the quality of the coal is said to be good. Greater the percentage of fixed carbon, smaller is the percentage of volatile matter. This also represents the quality of carbon in coal that can be burnt by the primary current of air drawn through the hot bed of the fuel. Next, about once the proximate analysis is done, then the coal must be taken for the ultimate analysis. As I told in the previous slides, ultimate analysis, it is nothing but the analysis of the carbon, hydrogen, oxygen, and nitrogen elements that are present in the coal. Now let us discuss about them in detail. The carbon and hydrogen content. How do we find out the carbon and hydrogen content that is present in the coal? For in order to find out this percentage, first we have to take 1 to 2 grams of accurately weighed coal sample accurately weighed coal sample, and it is burnt in a current of oxygen in combustion apparatus. The carbon and hydrogen of the coal are converted into carbon dioxide and moisture, that is nothing but H2O, when it is burnt. These gaseous products of combustion are absorbed respectively in the potassium hydroxide and calcium chloride tubes. If and Depending on the weight of these potassium hydroxide and calcium chloride contents, carbon and hydrogen percentages are calculated. These are the formulas that are used. The increase in weights of these are determined by using the formula. These formulas, that is, the percentage of carbon is calculated by increase in weight of potassium hydroxide tube into 12 into 100 by weight of the coal sample taken into 44. Okay. Now here the 12 is nothing but the molecule, the a weight of carbon, molecular weight of carbon, and 44 is that of the potassium hydroxide. And the percentage of hydrogen is calculated by using the formula increase in weight of calcium chloride into 2. 2 is the molecular weight of hydrogen into 100 by weight of coal sample into 18. Okay. Next, the what is the significance of ultimate analysis? Significance of ultimate analysis in context of carbon and hydrogen. Greater the percentage of carbon and hydrogen, better is the coal in quality and calorific value. If carbon and hydrogen content percentage is more, then the calorific value of the coal will be more, which indicates that the quality of the coal sample is very good. But the hydrogen is mostly associated with the volatile matter, and hence it affects the use of the coal for industrial applications. Also, the higher percentage of carbon in coal reduces the size of combustion chamber required. The amount of carbon, the major combustible constituent of the coal depends on the type of coal, and its percentage increases with the rank from lignite to anthracite. These are different lignite, anthracite. These names are given depending on the quality of the coal. Okay. Thus percentage of carbon forms a basis for the classification of the coal. The coal actually it is classified based on the amount of carbon content that is present. The amount of the coal is classified into lignite, anthracite, and like that, and this classification has its base on the amount of carbon that is present in the coal. Okay, next comes hydrogen. Sorry, nitrogen. Nitrogen has no calorific value, and hence its percentage in coal is undesirable. If nitrogen is present, then it is considered to be then it is considered that the quality of coal is not good. Okay, this is all about the ultimate analysis of coal. Thank you.